Hello everyone, welcome to Network Solutions. I am Mohammed Majid. Today we are diving into one of the most important data center switching technology, virtual port channel or VPC. If you are ever wondered how independent switches can act as a single logical switch to provide loop-free active-active redundancy without relying on spanning tree to block links, this lecture is for you. By the end of this video, you will know how to enable and configure virtual port channel feature on Nexus switches, how to build a VPC peer link and a peer keep live link, configure a VPC port channel toward a downstream access switch, verify VPC operations and confirm redundancy is working. So here is the two Nexus switches. One of the this and the other is one is the this. Two on the both Nexus switches are connected to each other. These two links will perform the VPC peer link bundle into the port channel. Ethernet 3 on each Nexus switches connect to the down to the iOS layer 2 switch on the interface Ether 0/0 or 0/1. This will become our VPC to the access layer. Let's configure the management interface on the both Nexus switches. Let's move on the Nexus switch R1. The interface management 0 IP address 1.1.1./24. No shut. Now move on the Nexus 9K2. Configure the port username, password. Config key interface management 0 IP address 1.1.2/24. No shut. Let's check the reachability of both switches 1.1.ping 1.2 DRF management because we configure the management interface. It should be ping. This will happen. Ping is successful. Now ping check the ping on the router to switch to sorry 1.1 VRF management ping is successful. We have configured the management interfaces. Now we will go to the enable VPC features on both switches. Features VPC enable. Now move on the next switch. Features has been configured. Next, we create the VPC domain. Both switches must use the same domain ID. This is what logical tie them together as a VPC pair. We will use domain 1. So let's configure the VPC domain on both switches. VPC domain and I will just VPC domain. Now we will configure the keep live peer keep live link on the both switches. Configure peer keep live link destination 1.1.2 so source 1.1.1. We are on Nexus switch 1, so we configure this. Now move on the Nexus 90 switch 2. Here keep live destination 1.1.1 source 1.1.1. Sorry, this is this will exact. This peer keep link is a heartbeat between the two switches. It does not carry data traffic. It's only and it is only job to detect the peer link switch is live. That's why we run it out of band over the management interface. Keep it independent of the data plane. Now let's check show VPC. Show VPC. Now peer is live. but we did not configure the keep live link, so it's a channel. That's why peer link is not configured. So this peer keep is live. Now we go. Now let's configure the VPC peer link. Now the most critical piece of the peer link, this carry VPC control traffic mag or synchronization and act as a backup data path. Best practice is to use the least two physical link in a port channel or redundancy. We bundle Ethernet 1 and 2. Let's configure the con- config interface E1 slash 1 dash 2 switchboard tran channel group 1 mode on. We configure static port channel on both sides. Interface E1 slash 1 slash 2 switchboard mode tran channel group 1 on. Now let's make the part of this. Now we will make this ether channel the part of the VPC peer link. Interface interface port channel 1 VPC peer link. This will convert to the STP to the network mode. Now configure interface PO1 VPC peer. Notice we use the channel group mode on here static port channel, which is the recommended mode for in the peer link itself, since it needs to it comes to independent and reliable. Now we will check these show spanning tree VLAN. Spanning spanning tree VLAN one. Show port channel summary. It will show the port channel is up. Now we will show VPC. Urgency is found. Peer link is alive. Peer urgency found. Okay. Once the peer link comes up and on both sides, the two switches will synchronize and you will see one of them elected as a VPC primary and VPC secondary. This is used for control plane decision, both straight forward traffic actively. Now we will configure the downstream VPC IOS switch. Now let's build the actual VPC toward or access it. This is in the link to give the as active and forwarding without blocking any port via spanning tree. So move on the next switches. Interface E1 slash 3 port mode trunk channel group 10 mode active. This will not work. So we need to enable feature LACP. LACP feature has been enabled. Now move back to the Ethernet 1 slash 3 switchboard mode trunk channel group 10 mode active. Same will configure on the Nexus H2 feature LACP. Feature has been enabled. Interface E1 slash 3 switchboard mode trunk switchboard channel group 10 mode active. Now we need to make both this channel to the part of the VPC. Interface port channel 10 VPC 10. This will make the part of VPC 10. We can use the other number, but ideally we use the same number as port channel has. So and the other same interface port channel 10, VPC number 10. That's it. That's it is using the LSCP channel grow mode active because switch iOS will bundle its two links using LSCP as well. The VPC 10 command ties this local port channel to a VPC ID 10. This ID must match exactly on the 9K Nexus switch 1 and 2 for the VPC far correctly. Finally, let's bring up the layer 3 interface on VLAN 1 so we can test end-to-end connectivity. Before moving on the interface, layer 3 interface, we need to configure the port channel on the iOS switch too. Let's log in. Enable config interface change 0/0/1 switch port mode trunk switch port trunk encapsulation .funq switch port mode trunk channel group 10 mode passive. On the Nexus side, so we configure this channel mode active, and on the other side of the Nexus layer 2, we configure the port channel mode as a passive. Now let's move on the layer 3 interface. Before configuring interface VLAN 1, we need to enable feature interface VLAN. Feature interface VLAN. We use this same command on the other Nexus switch. Now let's configure the IP address. Interface VLAN 1 IP address 192.168.1.1/24. Now shut down. Interface VLAN 1 IP address 192.168.1.2/24. Now let's configure the VLAN interface add layer 2 switch interface VLAN 1 IP address 192.168.1.3 subnet mask /24. Now shut. Let's ping from Nexus switch 1 to the each switch. Nexus switch 1 into the Nexus switch 2 as well as the layer 2 switch. Same will test here 192.168.1.1. This successfully. We mirror the same Nexus switch 1 configuration on the Nexus switch 2. So you want to see peer status, peer urgency found okay, and the peer link and VPC 10 both showing us up. If domain ID or VPC ID mismatch between the two switches, this is exactly we have not catched it. In VPC, check these the key fields. Peer status, peer urgency found okay, VPC peer link status is up, VPC 10 status up on both switches. Consistency parameter should show success. This confirm both switches agree on the VLAN, MTU, and the other critical settings as barely. Let's check the port channel summary on the all three switches. Let's check show port channel summary. Here we see the exact two port channels. This is a VPC and other is the keep keep live link. Show port channel active. Show port channel summary. Report the both port channels are up. Now let's move on the left switch. Show the channel summary. Port channel 10 is up,
both ports in ether 0 slash 0, ether 0 slash 1 is a part of the port channel 10 and it is in the next status.
Let's recap what we have configured today. Enable the VPC feature and created a match VPC domain on both nexus switches. Configured a peer keep live link over the management interface. Built a VPC peer link using static port channel across E1 and E1 slash 2. Configure a downstream LACP VPC toward the access switch on VPC ID 10. Verified peer urgency consistency on port channel status. It is exactly the kind of technology you will run into the real Nexus 7K, 9K environment. So make sure you practice this lab yourself in event. If this help